Okay, so here we are on dynamic memory allocation. So firstly, we have to discuss what is dynamic memory allocation. What is dynamic memory? So in the start of part 1 or in the start, we can discuss that memory is the most crucial element that we have. So dynamic we have, because if we load our program, we can initialize so many variables, too many variables, that it will take too many space on our memory side, and this will slow down our program and hang our program, and many other problems occur. So we have to write the efficient program. As a programmer, it's your responsibility to write an efficient program. To write an efficient program, you have to dynamically allocate the memory. Dynamically allocation of memory is that it's not about you then assign value. If you can make any variable and the value is allotted on memory side. Dynamic variable is different from this. What happens in dynamic memory? If we assign any dynamic variable, then the value will assign, then the memory will assign to that variable on the runtime. When we run that program on console screen, when the console screen has shown us, then the memory is assigning to that variable, that variable that has that allotted a dynamic memory. So this is how you can save your memory. You can make your program efficient by the allocation of dynamic memory. Let's see it in detail. Okay, so here we have functions like malloc, calloc, and reloc comes in, and let's see what are these things. Basically, malloc and calloc are approximately same. There is a little difference in malloc and calloc. No difference in actually on console screen. It's just on some backend. Calloc is different on backend, not on console screen. They both make a dynamic variable. Yeah, we can see this program. We are going to see this example. Sorry, just take too much time. So let's copy this program. And we are going to write this program here. Yeah. So now we are going to understand this program, what is happening there. So it is an int and variable. We just take an input on in and variable. And what we are doing here, this is the syntax of dynamic variable. Basically, dynamic memory is allocated through malloc calloc, and we can use malloc calloc only with pointers. So here what we do, we made a pointer name of dynamic array. We give the pointer name dynamic array, and how we can see that it is a pointer because of this static, and is equal to, we write here int static. Why we write here int static? And the variable type that we want to make, and the data type of variable that we want to make on runtime, that data type has to be given. We have to given that that data type here in this bracket. After that, you write a malloc, which is a function for dynamic memory. So we write bracket and n. What is n? N is a number of elements or a number of, you can say, variables you want to make on dynamic memory. Because it is a dynamic array, so you have to allot a number of elements. For example, if you want, say, if you write 5, so it will make up 5 dynamic variables, or you can say elements of array, dynamic elements of array. So these 5 elements or variable will be allotted. Their memory will be allotted at the runtime, not on the console time. So here we write size of, and here we write that int. It is basically a what is the syntax? Yeah, it is a syntax of assigning malloc, and same for calloc, maybe little different, very little difference. So this is about how we can write. You have to learn this syntax. So now check if memory allocation was successful or not. If dynamic array is equal to null, then we will write printf memory allocation failed and return 1. Now you can work the dynamic array. And if it doesn't work, and if it doesn't print this statement, it means that dynamic memory allotted. Don't forget to free the memory. Okay, yeah. Free is also a function. So when we allot this memory, when we allot this dynamic memory to any array or variable through pointers, so what we have to do, we use free functions to free the address, to remove that address before ending our program. So when we use that variable, we will free that dynamic array. So it will delete the all values and it will free from the variable, all types of variable, and this will remove the load of remove the load from the variable, from the memory of that variables. So this is the efficiency of dynamic variable. You can basically you can hollow your dynamic array just by using free function. You can dynamically allocate memory on the runtime through calloc function. So let's see it by running F11. Okay, here's a simple little program in syntax. Malloc was not declared. What? Malloc was not declared. Oh. Excuse me. What is mean by malloc was not declared? So I think we had to use some library here. So let's see, maybe it's a problem of a library, because it's so sometimes we need to use a Google also. If we don't find help here, we have go to Google. So for me .h false. So we will come here and we will write here library for pointers. The pointers is C. How about pointers and C? So is just yeah. Oh, not pointers, sorry, dynamic memory. Dynamic memory orientation. And then some library to solve this, allocate manually runtime. This is no dynamic memory like this, and I want just library stdlib.h. Yeah. Here is the library stdlib. So it is a library when we are dealing with for dynamic memory allocation. Memory allocation. So let's see. Now it's done because it gives an error because we didn't mention the library. So let's see. By pressing 3 here. So it doesn't show the statement. This is statement which shows that the dynamic array is not null, which means that the memory is allotted to this dynamic array. So this is how you can use malloc and calloc function and free function and realloc function. Realloc function basically reallocate any variable dynamically. So you can say it on Google by your own self for your practice. This is how you can work. You have to do practice with for malloc also. Now let's see our last topic, working with arrays and pointers. Yeah, it is very simple topic. Yes, because we already did that. but we can see that it separately also. So yes, here we can see working with arrays and pointers. It's a simple array. We can assign the variable. We can assign the num array to the pointer, and here we access it through static ptr, and here we write just static, and here we write static ptr plus 1, which means that we add 1 to ptr address, then show the value of that address, what value it holds on that address. So this is how, or you can use simply ptr plus plus. You can also see it from this, as we discussed above. So actually this is the way you can access the, you can work with arrays through pointers. So this is all about today's lecture. So in the next lesson we will explore even more advanced topics like structures and filing. So make sure to hit that subscribe button and stay tuned. Happy coding, and I will see you in the next video. And remember, practice makes perfect, so get your hands dirty with some board and have fun experimenting with pointers and memory in C. Until next time, happy coding.